Welcome to the today's topic. Our today's topic is mining time series and sequence data. Myself Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. In mining text series and sequence data, we will cover the sequence data. In that, I'll cover the sequence data. In data mining types, so what are the types are there? Three types are there. In first type, data time series data will be there. In second, sequential pattern data will be there. And in third, biological sequence data will be there. What is sequence data? So sequence data is nothing but sequence data in data mining is defined as a data which is points in the data set are reliant on the other points in the data set. So the sequence type of data that includes the name as sequence. So that is including the gene expressions. So in our body, the genes will be there. So the gene pattern will be some complicated. So what is the text related to that? So that will the sequence, the text will be in the form of sequence that call as a sequence data. So that the sequence data, it includes the gene sequences, weather data and other type of sequences. Suppose a sequence S is a set of ordered things indicated by S1 to S2 to Sn, right? So in that a time series data that will be as a stock market data. So time series data that is as a stock market data, sensor data. So that is an example of this. So that can also have the sequence type of data. So that is also following the some time series sequence. So time sequence will be there. Some data related to sensor. So that will also be called as a sequence data. So where each of the point in that will represent as a observation of at a specific point in time, right? So sequence data mining, how we are going to mine the sequence data. So particularly sequence mining comes under the sequence data in the data mining that already have told that have already has been proven that that is very useful while we are going to use it in a variety of fields, that in including we can use it as a in marketing. The web users, how many users that are clicking the web mouse on the web, so that will also have the data that is related to sequence, right? So on that we have to do the click stream analysis. Now in activity recognition problem, so the problems related to activity recognition, so in that we will find timestamp. So timestamp is nothing but that is having the information about the hours, seconds and minutes, right? So the data related to time span that will also have in the activity recognition problems that are commonly used for to arrange the time series. So that is related to time series data. Sequence mining purpose is nothing but that is to find the interesting pattern. So in that also we are going to find the interesting pattern of the data that is based on the some subjective as well as the objective evaluation of how the pattern is interesting. So the pattern that will be related to some genome sequence, that will be related to some time over the time data. So that will call as a sequence data. And while we are going to mine the data, so the purpose is to mine, that is to we have to find out the interesting patterns so that we can evaluate how interesting that pattern is coming out. So discovering these type of data that will comes under frequency sequence data, right? So frequency sequence data that is will be the in the data mining, but that to fetch that to observe that is very difficult task. But although we have to use some of the algorithm related to that is ARIMA and a priori, etc. So due to the combinational and exponential search space, So that will be used in to search about the interesting pattern. So these are the two interesting algorithms are there. So that will be used for to search the space. But that will also be difficult how we are going to search that specific space. In that, several sequence mining approaches that has also been published for the exponential search to search about the heuristic search, to search about that particular search space, right? So that is nothing but the exponential search. The GSP is nothing but that is generalized sequential pattern, which was based on the a priori approach. So that is based on the priori approach for mining frequent data types, mining frequent item sets. It was the first sequence mining algorithm. So that I am telling you, that was the first mining algorithm to search about the interesting sequence data. So that was used for the data mining. The GSP over the database have been numerous times to count the support. So in that in this method, the model have to count the support. So support for each of the sequence. So how many sequences will be there for each sequence? The support will be counted for that. And for after that, while we are going to generate the support, we have to use the candidate key. So we have to on that model, the model have to generate the candidate key. The sequence with a support count less than the minimum support will be cut off, will be removed, will be pruned. So in this model, in this technique, we have to first search about the particular support for each of the sequence, and then we have to generate the candidate key. But when the support count is less than set support, that particular sequence have been cut off, that has been removed. So how many types of sequence data is there in data mining? So a sequence is nothing but that is a list of events that will come in the chronological order. So particularly the sequence data in data mining can be classified into three of the kinds based on the characteristics of the data. So that will have the first type of time series data, that is data respect to the time. So data that is having the time data, the time with the data with the respect to time. The symbolic data is nothing but the data with lapse in the interval of time. So that is also the time series data, but that is having the interval in time for that. Third is biological data, that is the data related to sequence, DNA sequence. So data related to DNA and protein sequences. So these three type of data will be there on the basis of the events. First data, that is time series data. So a time series data is a set of collection of integer value of collected over a time period of time under the sequence data in the data mining. So the time series data is nothing but that is a sequence of integer value that has been collected over the time, that is called as a time series data. So in data mining, to mine that type of sequence data, we are using that particularly time series data. So the values that will be used as an integer that can be taken as a regular intervals. There would have some regular intervals such as each minute, hour and day. So the data can over by the day, time and hour and minute. So like that the data will be stored. For example, the stock market analysis. So stock market related data will be also the time series data, economic and sales data. For forecasting, the budget data. For analysis, utility data, that for the study, inventory data, the data related to income, the data related to workload, process and quality service. So all type of data will come under the time series data, are just few of applications for time series databases. So these are the real time applications where the time series data will be taken. So that is nothing but the sequence data. Now a time series data have the example. We will take example, a time series of air passenger, that is a database that has been stored in the R programming language. So the air passenger data is having the used as a below as a example of to demonstrate the what is time series spikes looks like. So the time series demonstration will be having the time series decomposition. So that the time over the data related to over the time. So it is composed into monthly totals of boxes as well as Jenkins International Airline passengers, that is from the year 1949 to 1960. So this data is having the 144 values. So 12 into 12. So that is having the 144 approx values. So in the x-axis that is having the time, and the y-axis that is having the air passengers over the time. So in the time that is having the years that is related to 1949 to 1960. So all the related boxes and airline passengers data that has been shown as a that is nothing but that is the time series graph. So that is nothing but that is time series graph. So here we can see here some of the here the lowest of the time is there, highest time, lowest, highest, like that the graph will be formed over the data of air passengers. So nowadays these type of time series are used to piecewise data. So that will use as a piecewise data approximation for the other analysis. So if the data analyst is have to do the further analysis, they have to do further investigations, they can use the data as piecewise. So some of the part they can use from that time series data. In this time series data, we can find a subsequence. So subsequence that we can also find, and when we can search for that also. So the time series forecasting or trend analysis is nothing but that we have to define the time series data that has been that in the form of trend analysis, that is going to create an integrated model that using the 4 primary aspects. So there are 4 primary aspects to do the forecasting, to the analysis over the time series data. So these are shown as below. That is, first is trend or long-term movements. So these type of dividations are there. So the data related to trend or the data related to long-time movement, it is going to define the overall direction in which a time series graph changes over the time in sequence data for the data mining purposes. So in the previous graph we have seen some data that has been taken over the time, over the year. So the data that is having the regular we can say progress, the development, in that the data, the direction will be taken in that trend and long-term movement data. So for example, finding a trend curve, we have to find the trend curve which including the dashed curve. So which includes some dashed curve that using the weighted moving average. So in the trend or long-term analysis, the data will be taken as a weighted moving average. So what is moving average? We will see. But we have to take the weighted of the moving average of that at least square approach. So the related data that will be used for the trend analysis and long-term movements. Second type of is cyclic movements. So cyclic movements that is having the long-term vibrations. So vibrations is nothing but some sound or related audio will be there over the time. So the data related to that around a trend line, a curve, that is known as a cyclic motion in the sequence data. So for data mining we are using the cyclic motions also. Third type is seasonal variances. So seasonal variances are the trends that is having the time series that is going to follow a follow during the similar season of multiple years. So in the same season, like if we can say if weather season is there, if over the we can say summer data we have to take rainy data. So like that, that type of data will be having the seasonal variances. So that has been recorded over the several years, such as holiday shopping season. So the holiday shopping season, like in we can say in December, the winter season will become. So there will be some shopping offers. So the data over the some holiday shopping, that time the customer, they can go for any holiday. So there they can also have the experience of purchasing. So that related data, that will comes under the seasonal variances. The data has to be de-seasonalized using an auto acceleration based seasonal index. So the data, while we are going to mine the data, the model we have to use as auto correlation based seasonal index to de-seasonize that data for effective trend analysis over the sequence data. Now the time series forecasting time trend analysis having the fourth variance, that is the random movement. So random movement, what is random movement? Random movement is nothing but that is having the sporadic changes in an organization caused by the changes occurrences such as labor conflicts or stated personal changing. So that related all type of that will come under the random movements. So in this figure we can see the components for time series analysis, that is having the long term movement, a trend, short term movement, that is having the seasonal variances and cyclic variances. So these will come under the short term movements. The third is random or irregular movements, that is having the we can say personal conflicts or personal changes. That type of data comes under the random movements. Now, what is the goal of time series data? Why we are taking the time series data? So, two goals are there for time series analysis. So, first goal is modeling the time series. So, that to gain the, why we are going to model time series? To gain the perspective, to gain the insight, a trend into the underlying forces that is going to generate the time series. Second is forecasting the time series. So, after that, the data we will get, we have the model have to predict about that, forecast about that. So to predict about the future value, here we are going to the model is going to predict about the future analysis. So future values of the time series variable will be forecast here. So these were the two goals over the time series trend analysis. So time series modeling is also referred as a decomposition of time series. So second name is also is there, decomposition of time series into these four basic movements. So that were the four basic movement, basically three. The second one divided into the two parts. So the time series variable that will shown as a time series variable y. So time series variable can be modeled as either the product of these four. These are the four seasons that has been counted. Y is equal to T into C into S into I. So that will the T, C, S, I is nothing but that is a variations. Four of the variation we have seen, that is nothing but that is that. So either we can sum of that, either we can multiply this. So time series data. Okay. So in that we have seen these three types of moments are there that has been multiplied, that has been calculated, that has been summed as a time series variable y, right? Now a moving average trend. So for the trend analysis, the model have to use the trend analysis, the average moving trend of that. So why to reduce the amount of variation that is presented in that particular data set. So the moving average, how we are going to count that? There is a example of that. If order of 3 moving average is there, so the y1, y2, y3 will be sum, and that will be divided by 3. y1, y2, y3, y4 divided by 3. So on y2, yn minus 2 plus yn minus 1 to yn divided by 3. So this is the moving average of order 3. So the similarity search comes. Then for when the model is going to do the trend analysis, there will be the similarity check. So the similarity check that is going to find the data sequence that differ only slightly from any given reference, any given sequences, any given query sequences. So that is also having the two types of similarity search. First is subsequence searching, second is whole sequence matching. So first the subsequence will be matched, and second method is whole of the sequence will be matched. So the similarity search is useful for financial market analysis as well as for the medical diagnosis. Now that becomes under the sequential pattern data. So what is sequential pattern data? That is having the symbolic sequences. That is also called as that is having the symbolic sequences. So an organized series of items, we can say occurrences, that will be documented with or without a specific idea of time. So that is that will not have the time series data, but makes up a symbolic sequence in sequence data for the data mining. So some of the symbolic sequences, such as the customer shopping behaviors sequences, some of the web click streams are example of cyclic symbolic data. So the sequence pattern matching is mainly used for the symbolic sequences. So while we are doing mining, the constraint based pattern matching is one of the best way to do the interact with the user defined data. That is nothing but that is symbolic sequences. So over the time, in that sequential pattern data, the best algorithm is there a priori. So a priori an algorithm to find out to use for this type of analysis. Below, for example, the sequence data is there, symbolic data is there, where we see the customer C1 and C2, they are going to purchasing products at different time interval. So that is a symbolic data that is having the purchase products. So in that, the TID, time, CID and event, there are 4 columns are there. That is having the some of the transactions. T1, that is having the timestamp data. The C1 type of that is a customer name, and that he or she have purchased wheat, rice and fruit. So like this, 4 of the other transactions are there, but the 2 transactions are similar. The 2 of the transactions only there are 2 type of transactions, but that has been used by the two of the customers, C1 and C2. So there will be these type of symbolic sequences will be the sequential pattern data. Now biological sequence data. So biological sequence are the nucleotide or amino acid sequences. So the data related to we can say DNA, which is having in our genes. So that data related to DNA sequence, the data related to protein sequences, protein structures, that is nothing but the biological sequences. So that is having the nucleotide or amino acid sequences structure, right? That is having the sequence structures. So biological sequences are the made of the DNA and proteins. So that is having the spikes, that is looks like spikes in our body as a DNA. So the biological sequences are very long and complicated while we are going to analyze that data, but that is having the some hidden meaning. So there will be have some suppose if one DNA is there, so there will be have some 16 bit long sequences. So there will have some A, D, A, C, S, like this 16 letter sequence will be there. So that type of data will have some hidden meaning. So example of that primary database is nucleic acid databases, that is having the GenBank and DDBJ. So these are the examples. Second example of protein databases are PDB, Swisspot, PIR, TREMBL, and MetaPsych. So these are the protein sequences database. So these analysis will be used for to compare, to analyze, to index, to have the analyze biological sequences, and that is going to play a crucial role while the bioinformatics people, bioinformation related people, they are doing the research on that particular genome sequence. And in the modern biology, they are using the biological sequence data. So the fact that all living entities that are linked through each other through the development, that is making the sequence alignment possible. So there could have the possibility of making the sequence alignment. So that tells us that the nucleotide, that is DNA and RNA, these are the two nucleotide and protein sequences of any living species that are closer in evaluation. So that comes under the evaluation. Biology must have more in common. So if they are related, there will have the some matching sequence data over the time. Now the method is there that we have seen the sequence alignment. So then alignment is a process of aligning the sequences to achieve a maximum level of identity. So identity is nothing but that is having the specific species, the living person, some specific biological sequence data. So which also determine what is the degree of resemblance, if they are matching to any other species in that. So that also comes under the alignment model. So in that we have to compare the alignment resemblance of the two of the persons. So the biological sequence data, that is having the substitution tree, that is used to find the probability of amino acid and probability of intersections. So this is the second model we can apply on that biological sequence data mining, that is substitution tree. The BLAST is basic local alignment search tool. That is a tool that is having the most effective tool for the biological sequence data mining. So these were all about the biological sequence data. What are the different type of biological sequence data? So there are basically three types of biological databases are there that has been existing. So the first is primary database. So the primary database is nothing but that is populated with the experimentally derived data. So over the researcher, over the experiment, the researcher, what the data he have taken, that will call as a primary data. So that is the single person related data. So that was used for the some experiment. So the data will have the genome sequences, macromolecular structures. So that type of data will come under the primary databases. The data entered here, that will remains uncurated. So uncurated means no modification can be performed over the data. So that will having the original type of data. The examples can be of a primary database, the nucleic acid databases, that is having the GenBank and DDBJ. In first example we have seen the protein databases, that is having the PDB, Swisspot, PIR and MetaPsych, etc. So the second databases comes at a secondary database. So the data is stored in these type of databases will be the analyzed result of the primary database. So the data which have been analyzed for any research, and that is going to give some result for that is going to give the some analysis. So that is comes under the secondary database. So the computational algorithm can be applied on that primary database, and that can have the meaningful and informative data for the analysis after the analysis that has been stored inside the secondary database. So the data that has been stored in the secondary database, that will have the analyzed data of we can say the primary database, that is having the the structured and informative information from that particular first database, that is primary database. The data here are highly curated. So here the data has been modified, has been curated. So the processing of data before it is presented in the database, so that has been analyzed and then it has been stored in the secondary database. Example of a secondary database is interpro, that is protein family, motifs and domains. So that type of data that has been analyzed over the primary data, so that will comes under the that is tell about the what are the different protein families are there, what are the motifs and domains are there. Second example is uniprot databases, knowledge bases, that is having the sequence and functional information, or we can say protein, on the based on the protein what are the sequence and functional information are there. Third type of database is composite database. So the composite database, the data entered in these types of database will be the first compared and then it will be filtered from that. So what are the data will be taken as a filter, that will be based on some criteria, the desired criteria that will comes under the composite database. So the initial data that will be taken from the initial primary database and then they are merged together to form as a under the some condition that will call as a composite database. It is going to help in the searching techniques, searching sequences very fastly, and composite databases that contains the non-redundant data. So the data will be filtered, so there will be no redundancy, the data will be original. The example of a composite database is OWL, NRD and Swissprot plus Tremble. So these were the composite databases. So that was all about the sequence data and time series data for today. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.